Good afternoon, ladies and gentlemen. I am Fabian Rich. I am honored to have the opportunity to share our research with you here today. As you can see, in engineering, the problems are treated based in a logical algorithm consisting of three important parts. First, the set of investigation and fault detection. Second, the scientific reasoning and organization of work. And third, the development of solution and check of results. Today, I am going to talk about the failure in machines due to the fatigue failure phenomenon involved. I have divided my presentation in four several parts. The first one is the context. Second is the causes. Third, the problem. And finally, the solution of the problem. So, let me start by explaining that in mechanical engineering is very common link two pieces with a bolt. It is to say, some machines are compounded by various mechanical parts that need to be joined. On the other hand, the operation of these machines generates a cyclic load over the bolt. These loads are one cause of the phenomenon of failure by fatigue. Specifically, the operation of a machine generates a relative movement between their parts, since they are joined with both, and the movement of a part with respect to the other part is the main reason of bolt failure due to the loads. Well, moving on to problem, in the 21st century, the machines are used for developing different tasks that make life easier for people. However, the frequent industrial operation of these machines generates a periodic expenses due to maintenance or damage that are generally associated to the failure of connection between parts. In other words, the problem of a periodic maintenance or reparation for damage in machine is a result of a bolt geometrically poorly designed or with bad materials. In conclusion, it is bolt failure is a known problem, and it has been the cause of a numerous machine failures. So finally, and given the previous problem, the solution that should be implemented for this problem is based in two parts. First, improve the manufacturing process of bolts with the objective of make piece uniform geometrically and reduce the cracks in the bolts. That is to say, a piece without imperfection has least possibility to fail. Second, in some cases it is necessary improve the material, adding other compounds or replace the material with one of a higher fatigue resistance. Now, let's look at the graph 1. This graph shows the variation of maximum stress in megapascals for AC4314 alloy steel in function of the number of cycles. Also, the graph shows the curve for four different tensile strengths and variations in the composition of material. As shown in the four curves in the graph, the maximum stress decreases when the number of cycles is increased. As you may know, when a piece subjected to cyclic loads, their resistance to fatigue decreases and makes the material fail faster. Finally, if these two aspects of bolts improve, the fatigue failure in bolts will be reduced, which will imply a reduction in the maintenance and the reparation outlays of machines. I hope my rather rapid explanation was clear. Thank you for seeing this video.